In this example problem, we're going to be using another regression example. This time we're going to predict how a student's test score is affected by the number of hours that they study. But instead of going through and making an equation right now, we're really trying to answer the question, how much does studying help your test performance? And we have a data set here of 8 students with their accompanying hours that they studied and what their raw score ended up being. And just on visual inspection right here, we can kind of see a trend going on right now where these students that got in the 90s all studied for at least 8 hours. And it looks overall like the number of hours studied as it goes up, the students' performance on the test went up, kind of makes sense. But we're looking for how much does X make Y change? And that's the slope. And we could do a regression equation. We could go through and find the slope of this and come up with an equation that says, according to our analysis right now, every additional hour studied should increase your test score by X amount of a certain amount of points. But that probably isn't the universal truth. Like we don't have enough students. We're only taking data from 8 students, and it's not 8,000 students. We could have, information here where if we took another sample of 8 students, they got a different slope. That's kind of the way that regression works. You never make perfect predictions. One way to get around that is instead of predicting an exact point, you predict, as it says up on top right here, a confidence interval. And a confidence interval is basically saying we don't know exactly what the slope is, but we are confident that it exists within a certain range. If we had information from all of the students instead of just these 8, we think the overall population slope, if you will, would lie between one point and the other. And the math into doing this is time consuming, etc. The easiest way to get about it is just to use the data analysis tool pack to give you your summary output because the confidence interval for a predictor variable for a dependent variable independent variable is actually in the regression output. So I'm going to go and do that really fast. Data analysis. I want regression. I'm going to hit OK. And here, let me go and clear these out. Again, you have to unfortunately clear these things out and change your settings every single time you use this because it by default always holds on to the last thing that you had. Down here says we do not need to display residuals. Let me make sure those are off as well. Okay, now we're all set up. Our Y range is our actual test scores, and I'm going to put the header in there, so C3 to C11. Our X range is our X values, or these study hours, and I'm going to put the header in there, so B3 to B11. I do have labels on. For my output range, let me just go throw it over here into cell A14, and I hit OK, and Excel is going to return this to me right now. And with this information, we have our regression equation. It would be 71.2 roughly plus 2.37 times X, the number of study hours they had. But we're not concerned with this, with the slope that we got just from these 8 people. We're more concerned with what range we're confident this slope, true population slope exists between. And that's actually what these numbers are over here. These two figures, the upper 95 and the lower 95, we'll just make them a certain color so we can identify what we're talking about here, is our confidence interval. Yes, we came up with a specific figure for a slope, about 2.37 points, but it was only based upon 8 students. If we had information about 80,000 students and we had a better set of data to work with, we would estimate in this case with 95% confidence that the actual slope we would have is 0.84 to 3.9. And that's exactly what I'm going to put down here. You can state with 95% confidence that the true slope is between 0.84 and 3.91 after we round up. So if somebody said, does study increase your performance on a test? You can pretty definitively, in this case, say yes, because even at the lowest end of this, we still have a positive slope, which means y is going up as x is going up. So interpreting slope, you can say with 95% confidence, the true slope is between yada, yada, yada. It means in English, each additional hour spent studying will increase a student's test score by somewhere between 0.84 points and 3.91 points. So that is the easiest, quickest way to go about this is to use the regression analysis out of the data or the regression equation out of the data analysis toolpack to come up with your numbers. Real fast, I will show you how this works. The only problem with this is this summary output has 95% at all times. And that is the most commonly used percentage that people will use for confidence intervals. They say if you have 95% confidence, your findings are, as they call them, statistically significant, which is why Excel defaults to that number. But you can do this by hand if you want to. The first thing that you're going to need is what they call your T statistic or your T critical value. And T critical value is basically a ratio that you have of how far your residuals are off from the standard error that you have. Real mathy stuff in here, but Excel has a formula that will give it to you, and it is the t.inv function. In this case, we're going to use the t.inv.2t function, and 2t means two-tail. It means that being below this or being above this would both be bad. If we said, that it increases your study hours by 12 points for every hour, or your grade by 12 points for every hour that you study, well, that's above our high end. If we said it reduces your test score by studying, that's below our low end. So we care about both tails. So just to put the formula up in here, it is equals t.inv.2t, and I'm going to open a parenthesis. And the input, this function asks us for two things. The first one is the probability. And as I wrote up here, the probability is always the complement of your confidence interval. If you have a 95% confidence interval, you want to be 95% confident in your findings. Well, the probability that Excel is asking for is the probability you'll be wrong. So if you're 95% confident, you're 5% unconfident. Or you're giving yourself a 5% chance of making an errant statement. The second thing you have is your degrees of freedom. And degrees of freedom is how much leeway you want to have in your confidence interval. And the general formula for this is n minus the number of variables that you're taking into consideration. So n is the sample size, how many we have, and this is a sample for 8 students, 1, 2, 3, 4, 5, 6, 7, 8. And we're testing for slope. And to find our slope, we had to use two variables, study hours and actual raw test score. So down here, my degrees of freedom is going to be 8 minus 2, or 6, if you can do that in your head, which I'm sure you can, and hit enter, and you get 2.447. And that you can use in this formula down here to make your confidence interval. The formula is that the predicted population slope, that's what that B with a little hat on top of it means, equals B, your slope, plus T critical times the standard error that you have for your slope. So for us over here, for the low end of our confidence interval, I'm going to say this is equal to the slope that we got from our regression analysis, and that's right up here as 2.37313, yada, yada, yada. And it's plus or minus. I'm on the low end, so I'm going to start with minus that t critical value times the standard error of our slope. And Excel gives you that information as well. Right over here, we're looking for the slope that study hours causes. The standard error for it is 0.62. And what does the standard error imply? It means it's a standard deviation for slope. It's the best way that I can describe it. It basically means that it's 2/3 of the time, roughly. If we kept doing samples of 8 people, our slope would be somewhere between 0.6 points below this one or 2.6 points above 2.37, or if you will, 1.8 to 3, somewhere in that range. And when I throw that in here, I come up with 0.8406992. If I knock that down to just 2 decimal places, it's the same number that we have up here. For the high end, I'm going to use the same formula, but this time I'm going to use plus. So this equals our slope for study hours, 2.373, plus that t critical value times our standard error for slope, and putting all those inputs in here as well, we come up with 3.905569. And as you can see, that's the same number that we had over here. That's the 2 decimals, formatted 2 decimals, 3.91. So Excel will grab 95% by hand for you. If you are ever looking for a number besides 95%. Just follow this procedure over here for whatever percentage you're looking for.